Okay, so welcome everyone. It's good to see you again. Appreciate, I know some of you had other potential commitments, and I appreciate you navigating those. So today we're going to be building on yesterday's discussion regarding capturing, interacting with geographic data within HMS models. In order to do that, we're going to, in the next hour, build up a model making use of geographic data in a very simple way. And hopefully it will, although it will be simple, it will illustrate, some of the basics enough that it's something that you could undertake yourself in more detail for an area of your interest. Okay, we'll get as far as we can. I do have other models of this sort featured in videos that take it further, and I'll see if I can refer you to some of those models, those who wish to go further. But maybe we could jump into this, and as I say, we'll see how far we can go. Okay, to that end, what I'm going to do is share my screen here, and I'm going to go over to AnyLogic, and I'm going to close all models here, and I'm going to create a new model that is going to be here, new model, simple GIS mobility, okay? We're going to have the time frames of this model, the time units, excuse me, characterized in hours, and we'll say finish. So what did I do? I went File, New, create a model, and I chose it to be hours, and I've called this simple GIS model. And I'll make successive versions of it. So I'm going to make it version 1. Version 1, so that I can easily go back to a previous version if it proves problematic, and I can easily distribute them to you, and you can be clear if you have the latest one. Okay. We have our model, and we are going to have a population of people within this model and be building up some of the familiar structures from past model building. But really, I do want to get to the key components of this from the get-go. And to do that, we are going to be focused on main and be adding in some components that will let us situate the model in a jurisdiction of interest. So what I'm going to do is I'm going to go here to the palette, okay? And within the palette, I'm going to go to the space markup area of the palette. And within space markup, you'll see a set of components that are widely used for discrete event modeling, involving particular indoor facilities and affordances in them. You'll also see some related to pedestrian movement and movement on rail lines, etc. Some focused on industrial settings. But the ones that will be focused on here are these GIS ones. I should note there's also some generic ones for indoor movement to route agents and resources through certain paths. But we're really going to be focused here on the GIS. Come on. So I'd like you to go to the GIS map, and I'd like you to drag it in. So click on it and drag it in and place it in this area, extending down from this origin point. Okay. Now, I'm going to be going through a set of interactions with this map, and it's actually quite important to go through the sequence in the ordering that I described, to allow you to make sure that we stay in sync. I'm going to be interacting with it on a more slower basis to give time for people to catch up here. So here we go. Here's our map. We're going to double click on the map. So in other words, having dragged it into main, we're going to double click on it. Okay. And then if you double click on it, what you should get is a small box up here, which is going to allow you to engage in searching for particular resources, regions, municipalities, etc. So we're going to click on that. Okay, so how did I get there? Again, I double clicked on this map. I clicked on this text box. You're going to select, and this is important, region, not point, region. Okay, I'm going to say region. Okay, and we're now going to select a region here of interest. I'm going to select one from our home region, with which some of you are familiar, Saskatchewan. If you'd like to choose another municipality, you're welcome to do so. Okay. And here I'm going to start typing it in. It's best and a good practice to list the particular municipality name and then the name of the next larger unit. For example, the province in this case. That reflects the fact there could be multiple municipalities named a given thing, and this will make it less ambiguous. Okay, so I'm putting the province here. Again, you're welcome to say Toronto, Ontario, or Kitchener, Ontario, or Montreal, Quebec, or what have you. Okay, and now I'm going to press enter with this, and you'll notice that it picks up some things that it characterizes as regions here. Now, the first of them is what we want, and this is a reflection of a general feature in interacting with GIS databases. Often, you'll search them, and they are large enough that they may have many types of resources that at some level match your query, but often your interests are quite focused on one of them. So in this case, we're focused on this first one. Again, if you're choosing Toronto or another municipality, the details may differ. So having done that search, I got here by pressing enter. I believe I could also alternatively press this little button there, the search, and you'll get here. Okay, now with this list, this GIS search results list, right? What you're going to need to do is you're going to right-click on this, and you're going to select here the convert to GIS points or regions. I do want to address anyone working on a Mac. It's possible that you will have been stymied in this whole sort of effort because you have not seen this point and distinction. So if you don't see that, you may have to right-click in the search area and then click back in it to see this distinction. If you see this distinction, you can ignore that. It's just on some Macs, I've heard that sometimes this point region distinction does not come up initially, and it therefore you have to right click on this this sort of area and in the search area and then click back on it. Okay. In any case, we have our, you'll enter that query, you'll press this or you press enter, and you'll have this. And the key thing, in order to take this from just being an entry in the database, an entry of a region in the database, to something that is meaningful to your agent-based model is you'll need to say convert to GIS points or regions. Okay. That will place the information on this into the model, on this municipality. So I'm going to say here that convert to it. And you'll notice by virtue of it, it turns golden. The color of this indicates that it's already been created. If you right click on it again, you'll note that you don't have that option to convert. Okay. Great. Now, there are cases where you may search for something here. I'm not asking you to follow this, but it's possible you'll search for something, like you'll search for Sydney, Australia, and I'll search, and nothing. It's possible that you'll have problems with something coming up. In this case, it was no problem. I will say that in my experience, there have been times where I haven't seen something come up here, and I need to double click on this, and I need to sort of move around on the map to show the region in which I'm interested. But we've already gone through that, and in this case, it seems not to have been a problem. Okay, so that was just a sort of advisory there. Okay. So what I had searched for was Saskatoon, right? We had already seen that, and that's up there. You'll notice by virtue of me having sort of right-clicked in the search results and created it, it's actually highlighted here. Even though it's not in the search results anymore, it's highlighted there. Now, I need to zoom in on it, okay? So to do that, you can, again, double-click on this. Double-click, make sure this is visible. And you should be able to use the plus key to zoom in. You could alternatively, if you have a mouse, you can use the mouse wheel to zoom in. So I'm successfully zooming in. Saskatoon is becoming larger. There it is. And it's starting to fill up the area allotted. Okay. I think that's as large as I'll go here. Okay. The reason I'm emphasizing this is we're going to be searching for resources within Saskatoon. Okay. And here we're going to be seeing how we can find resources within the context of a given region that we've already searched, already found and created. Okay, great. Okay, so we are going to double click. I'll click within this, but I don't think it really matters, so that the search box is visible here. Okay, now we're going to search for a point here. And we're going to search here for school. Okay. And I'm going to press enter or here. And okay, so it is showing schools in a wide variety of regions here. Okay, so give me a second, and I'm trying to find out why it's showing me such a large number, because this is not what I intended. I intended it to be specifically the within the region that I had selected. Okay. And right. Right. So we are okay. Pardon me for a second as I just I don't have a recollection of having encountered this before, and it may be linked to the fact that we again had the ability to search for things that were not visible. Yes, Matthews, if you want to say something.
If you specify Saskatoon after school, it shows only in Saskatoon.
Okay, yeah, thanks. So I also went over to the main model here, and I went down in presentation and went to Saskatoon and selected that as a region. That may also help. So in other words, it knows about Saskatoon because I created it before, and it may be that will help it narrow it to specifically to that. I'm not positive, but I think what you're saying is school Saskatoon doing that as a qualifier. Is that right? Yes. Okay.
Yes.
Yeah. Good. Thank you. That's helpful. Yeah. Thanks a ton. Really, really appreciate that. Okay. So here's a set of schools. And these are located within this GIS region of Saskatoon. We're going to be turning these into agents, okay? And in order to do that, we're going to go and select the first 6 here, okay? Here we go. And right click, and we're going to convert to GIS points regions. So we're going to remember those particular 6. Okay. Okay. Now, really beyond noting these particular points as points, what I do want to do is to actually add them as agents. So I'm going to come back to this in just a second. But first, I'm going to go to main, go back to the model. And I'm going to add here in the model a new agent type. And I'm going to say a school. Okay. And we're going to say finish, and we're going to go to the palette, and we're going to go down to this area of the pictures of the palette, and we're going to add in a representation of a school. And I think we will add it like this little house component. And I will call it a school. Let's not call it a warehouse. Okay. School image. Okay. So I've added that to school. Okay. And the main point here is not the picture. That will just provide a visual representation. The main point is actually the ability to have an agent called school that we could then add. So let's go see how we can do this here. We're going to go back to our map with our school agent having been created. We're going to go through a similar process to what we just did. So just to allow me to have been confident in repeating what I did, I'm going to go back and click on this region. I'm going to double click here I'm going to say school Saskatoon. Here we go. Oh, excuse me. Since I already, excuse me, folks. I could do that. I would find these again, but I actually just want to do it right here within this window. We already have them selected. I don't need to get them selected again. I could simply reuse these. I'm going to right click. I'm going to say create agents at selected element, but I'm going to first do it for all 6. So I select those 6 again, create agents at selected elements, and I'll say school. So now we have schools created. We have agents, a set of agents on a one-to-one basis with those schools created at the actual physical location of the school. Okay. Next, we're going to go through and we're going to create a population. I'm watching the time. We're going to create a population of homes. We could have gone through the same thing for clinics, but in the interest of time, we focused on creating agents at certain locations, defined locations, which we just did with school. You'll notice that there's a agent for each of these schools because we had said create agents at those elements. So we have these names. Okay. Next, we're going to create a population of homes. Okay, or we're going to create homes, and we're going to as a home as an agent, and then we're going to create a population. To do that, we're going to go to the palette. We're going to go here. Oh, excuse me. We'll just go to the model as a whole. First, we have to add the agent type. So for the model as a whole, we'll say new agent type. And what agent type will it be? It'll be a home. Okay. And we will open up home. That one's open. We'll go to the palette. We will go down here to pictures. And we will drag in a house picture to the home. Now, this home will have this depiction as a illustration here. We are going to go back to main, and we're going to create a set of homes. To do this appropriately, I'm going to first go to the palette to the agent. I'm going to open a parameter, and this is going to be called, we'll say count homes. Just do that. It'll be an integer. Integer. How did I do that? I had to go up and find it. And I'll say by default 50 homes. Okay. That's if I don't specify it separately using the in a scenario, an experiment. Okay, let's go. Let's go create our homes. Now, homes are going to be different than schools, and that schools were placed at very defined geographic locations. By contrast, homes are going to be placed at random locations within the region. Okay. And we have to create a population of them. So we are going to go here to the palette, to the agent palette, and we're going to drag in here, excuse me, to the project. We're going to drag in home. We're going to drag in home here. Okay. Oh, uh-oh. I just deleted school. Okay. Okay, sorry, folks. I did something accidental here, and I may have screwed up. No, schools are back. Okay, thank goodness. Okay, I didn't mean to delete it. I did by accident. I'm going to go. Oh God, I just deleted homes. Okay, I don't know why. Okay, it's gotten into. Excuse me. I'm just going to close this and open it up again and resume my. Somehow it got in some mode where it was not allowing me to. Okay. Okay. It is proving problematic. Pardon me for a second as I fight this battle. Okay, so there we go. Okay. So I add in home, make it homes, and it's going to be a population of agents. And how many agents is it going to be? It's going to be the number given by count homes, that parameter. Good. Okay. Okay. So we have here a population of homes. And what we're going to do is we're going to go to homes, and you'll notice that for this homes population, there's an area of it of the properties for it called initial position, and you're going to specify that. Okay, and here we're going to put in the latitude, longitude. Okay, and in order to do this, we're going to convert this latitude and longitude. Instead of being pre-specified values, we're going to specifically use the values for a location. Okay. So we're going to need to set this to a location based on the location of this home. Now, in order to give it a location, we are going to have a location parameter within home. So go click on home, and we're going to need to add a parameter to home called location. Okay. And the type of this parameter, so this is going to be an assumption about a home that is going to be set by the enclosing population. So for this parameter, we're going to scroll down and we're going to say that the type of this parameter is going to be, my recollection is it'll be a point, okay, for this. So it's going to be other is the type, and the type is going to be point here. So what did I do? I went to home. I added a parameter. I need to give it a location. The parameter is called location. It has a certain type. It's not a string. It's not an int. It's not a double. It's not a home itself. It's a location in geographic space. And the way that we characterize that is we go and we say other here for the list of types because it's not on that list. And we would say it's of type point. Okay. Okay, make sure your model builds. It's building here. Okay. Okay, so having done that, having given each person the ability to have an attribute that specifies their location, we're going to now take advantage of it in the population that contains those homes. So back to main, let's select that population. We were working on it before, and we had set it for the agents to be placed in a certain latitude, longitude. It was fixed at the time. Let's go change it to be a dynamic value. Okay. So to change it to be a dynamic value, you're going to pick this. Okay. We're going to have it depend on the location. Okay. So these are going to be dynamic values depending on location. But before we do that, we're going to fill in what the location is. Okay. We're going to need to say how to determine the location. So what we're going to say is this dot, and then the name of the municipality, the name of that you chose. So if you chose Toronto, it'll be Toronto. It's actually given by, and I'll show you where you can find it. Excuse me, under presentation, under, okay, so under level, under maps, there it is, Saskatoon. So are we going to do this? We're going to say this dot Saskatoon. You could actually alternatively just say Saskatoon. It's referring to Saskatoon, which lives in Maine, and thus I said this dot Saskatoon dot. Okay, so it's within me in Saskatoon. We're going to need to do dot random point inside. And we need to call that. Okay, so we'll just do begin paren, end paren. So this is calling. It's asking for random point inside the Saskatoon region. Okay, that's for the sort of general rule for agents within this population. We're going to give them successive random points. Each agent in turn will have its location set as a random point inside this region, Saskatoon. Okay, so what will its initial position be? Let's go look here. So its latitude here is going to be here. We're going to set this to be self dot location dot get latitude. So self is referring here to the home being set up. You're asking for its location and the latitude of that location. And then the longitude, self dot location dot get longitude. There we go. Just like that. Okay. So I've done a number of things here. I'd like to rehearse them in case anyone has been lost. Okay. So just from the top, what we did was within Maine, of course, we went and we dragged in a GIS map. We double-clicked on it. We found a region named Saskatoon, Saskatchewan. We went and we right-clicked on it. We said create region. We then, having created that region, the key thing was that we went and we double-clicked again to make sure that was that searching ability, and we searched for points within that region for schools, and we said school, Saskatoon, so to find the schools in Saskatoon. We then said to create points or GIS points regions for those, and it's creating points. That was done. Having done that, we then went and we created a school agent. A school agent. That school agent was associated with a certain image. We went back to Maine. We again went back into the GIS interface, and we had those search results from earlier. And we said to create for the first 6 that we had said create them as points, we right-clicked on them as a whole and said create agents for them. Those created agents of type school. We then went and we created an agent of type home, and each home was associated with a parameter location. That parameter was a point in geographic space. So it had a certain type. So homes have a certain image, and they have a attribute that's a location that's specified by a geographic point. That's good. Okay, so having done that, we added a population of such homes here, and we needed to specify a rule for the location for each successive home within the population. How do we determine its location? We said the location is at a random point inside Saskatoon, inside this region that we had searched for, and which we had said create region. I should have emphasized that earlier. When we searched for Saskatoon, we got a result. We right-clicked on it. We said create region. That was in that first use of the map. Okay, so within this region, we're selecting a random point inside the bounds of this geographic region. Okay, and then for the initial position of each successive agent, we need them to realize just setting this location, like it doesn't magically know that's their true location in GIS space. It's called location, but it doesn't connect the two, right? We have to make it their in fact location, their position, by referring to that location's latitude and longitude, by placing agents at this latitude and longitude. Okay, so that's the broad sweep of what we've done. A lot of pointing and clicking and selecting things and right-clicking to create things. And I apologize, but it shouldn't be lost on us that we're interacting here with GIS databases. Okay, one of the points by which I live is the admonition from Jeff McDonald that we build early, build often, and run early. Well, he actually says always keep the model within 30 minutes of being runnable. So I'm going to right-click on simulation. I'll say run here. And here we see schools. We also see homes. The homes are distributed randomly at random points inside the bounding box of this region. Now, I will note that if you go and you zoom in, and I screwed up by zooming out, but if you were to zoom in with a mouse or otherwise with keys, what you would find in movements on the trackpad, what you would find is, in fact, okay, now I've really screwed it up, that certain of the homes may be located at a place that is unrealistic, right? You might have a home here which is placed, for example, over the river. And that's part of not binding it specifically to an known existing geographic location of a home, but rather placing it randomly inside a region. There are ways of trying to deal with that and trying to make sure it doesn't reach obstacles, and more sophisticated regions might delineate land regions, and you could locate it within the two sides as different regions. I'm not going to go to this. Okay. But fundamentally situated agents here, both with fixed locations representing particular known resources and geographically placed, or things that are placed within certain regions that are geographically grounded. Okay, so far so good. let's add in, as time allows here, we have about 20 minutes. I'm going to add in a little bit of additional texture. Okay, so we're going to go to the model, and we're going to, first of all, I'll save this as a new version. It certainly merits that. Okay. I'm going to go, I'll say new agent type person. Okay. We're going to give them a picture down here. Give them an anthropomorphic image. And now we are going to give them further. Excuse me. In the palette, we're going to go here to agent, and we're going to give them a home. This home is a parameter for agent. It's going to be an assumption we make about an agent. Traditionally, parameters are used static values, and they serve both to denote the value and to communicate it from the point where the agent is created. Most commonly, a population that encloses it, but alternatively, when it's brought into the model as an open member of an open population, it can be specified there, the assumption about it. Okay, so for this parameter, let's go to its type and set it to be home. It's of type home. It represents a home. And we'll give it a value that is explicitly not defined at first. If it's not, excuse me, it's not at first. If it's not specified, it'll be by default. No, we have no specific value that we know. Okay, so this is within a person. Each person as a home is the idea. Okay, next. We are going to go to main, and we're going to add a population of people. But before doing that, we're going to have a parameter that will specify such a population. So we'll go to palette. We're in main. We're viewing main, and we're going to specify a parameter here. Parameter will be the population size. This is going to be an integer. Its default value will be 250. Excuse me, I think I'll say for count of homes, we did what, 50. So I'll say, yeah, I'll say 250. That's fine. 250. Sorry. Okay. It's an integer. I had to go up to find integer. Okay. Okay. Having set something that's called population size, we're going to go back to projects. We're going to drag in person here. And again, it's proving a bit truculent, but with patience, I'll get it to do that. I'm going to make it a population. So I called it population, but it doesn't become a population until I select it and I go to its properties. I say population of agent. Its initial number of agents is this dot population size, or just you can say population size. Okay. And then we're going to set its home. A given person's home is going to be given by homes dot random. Homes dot random. Here we go. So each person needs a home. Indeed, that is the case in the world. Each person needs a home. Remember, the home it's a parameter, so it needs to, the assumptions about it need to be specified by the thing that creates that agent. In this case, it's the population. So the population needs to specify what assumptions to make about the homes. And here we're drawing the home with equal probability from the set of homes. Okay. Great. We're drawing it from the set of homes. Okay. So here people are going to be bound to homes, and we have homes already assigned to locations. So persons will be associated with some home location, but we need them to actually go there. And we're going to set up a very simple state chart, given the limited time, that will have them go between their home and the nearest school. And we'll see how we can have that mobility in GIS space. So to do that, we're going to go to person. We're going to be setting up a state chart within person that's going to encode a set of states, the actions that can change those states, going transitions from one state to the other, and finally, that give the rules under which that govern those transitions. So to do this, I'm going to go to person. I'm going to add a state chart. And this is going to be mobility state chart. Okay. And we're going to then add a state at home. We're going to add a state at school. And you could easily elaborate this, and in a past lab, we've done that. We're going to have a transition here from school to home, which is going to be based on, this is going to be called, go to school. And I could add an intermediate one. In the interest of time, I'm not going to do this. I could have an in transit to school separate from an at school, and actually have a arrival transition from that. That would be meaningful if you're really interested in the behavior during their movement, if that has some significance, if they're mixing with other people there, if you want to keep track how long it is, etc., you might do that. Here, I'm just going to have them, I'm not going to distinguish between when they're in transit and when they've arrived at school. So you're going to go to school. It's going to be a timeout of 16 hours. Again, we chose hours as the time unit, so we specified that. And they're going to be going to school. Now, let's go show how to do this. So we're going to need, if we go back to school, you'll notice here that school does not have an explicit location here. Okay, we haven't set up explicitly the rules for or we haven't given it a specific location. So what I'm going to do here is go to this at school. The action, when it triggers after 16 hours, I'm going to say move to, and we're going to ask for the closest school to me, okay? I'll show how to find this. Okay, move to. We're going to need to find in Maine schools. There's a collection we're going to have, excuse me, in Maine, there's going to be a set of schools, and we're going to go to the nearest one of them. Now, in order to do this, we're going to need to actually group together those, so we can ask sort of what's the nearest agent in that collection, for example. And I'm going to do that. Forgive me, I'm going to come back to this in a minute. Maybe I'll do the easy one, and then we're going to do the one that will involve a couple steps. So the first thing will be mobility state chart. When they first come in, we're going to have them move to their home. So I'm going to say move to home dot location. Okay, dot location. That's going to move them to their home. We're then going to deal with the somewhat more involved challenge of having them go to their nearest school. That won't be hard, but it will involve grouping agents so that we can end up sort of finding the nearest one. Okay, here we go. Okay, so we're going to have them go to their home initially. Let's go run the model and make sure they go home. Here we go. We built it. We're going to go run it and make sure that, in fact, they all start at their home. And they do, as you can see here. They've all now been placed at their home. Everyone is a home, and they've gone to that home initially. Okay. So, in fact, we do have a home. Let's go to Maine, and let's do something similar for schools, but we're going to, in fact, go to the nearest school. We've already been using the GIS functionality to give a location to homes, and now we have people going to those homes, actually moving to those homes. But let's add a bit of subtlety and have them go to the nearest such school. Okay, so what we're going to do is we are going to select, we're going to Maine, we're going to select each of these, each of these in turn. So I need to right click on each. I'm being a little bit careful to make sure that I have got all of them. Okay. Each and every one. I'm going to right click. I'm going to say create collection. And that's going to create a collection called schools. Okay. You notice it's not a population because each of these is an individual school. But this is a collection of them. How did I do that? Well, I selected all of them, and I'm not going to go through it again, but I right-clicked and I said create collection. So now we have a collection of said schools in Maine. And we're going to seek to find the closest one. One step at a time. Let's go back to person. We're going to go here, and we're going to say, okay, take me to a school. Okay, so I'm going to say move to. That's how we move. You may remember that from our a mobility model we built earlier in sort of abstract space. Here we're actually doing it geographically. It's actually choosing routes. It's going along roadways. It's assuming a mode of transportation, by default vehicle, and it's actually routing accordingly. There are different such modes different such locations for different modes of transport, including bike or walking, for example. Okay, so I'm going to say move to. And I'm going to say main.schools. So here we have a set of schools. And for now, I'm going to say, I'm going to choose a random one within that. Okay. Excuse me. Excuse me. No, I will do get nearest agent within the schools. So here I'm going to ask for among the schools, what's the nearest agent to myself? And I'm going to move to it. That's the action. Now I need a semicolon because I'm saying this is an action. This is a command. Do this. I need a semicolon. If you're just computing something like saying 16 here, or you're saying, use use the home's location or what have you, you don't have to do that. You don't have to have a semicolon. You're just using a value. So here there's, excuse me, this should have a semicolon. Here, like home.location, I get that. And then I'm saying move to it. There should be a semicolon there after that. Here, this is a command, move to it. By contrast, something like this, where we have homes, this doesn't need a semicolon because I'm just determining a value. It's a formula. I'm just using this formula to get the latitude, to get the longitude. It's not a command to change something. But here at person, it is a command. We're saying, move to this location, and the same thing here. So we need semicolons. Okay, so let's build and let's observe the induced behavior, the emergent behavior, the behavior that results. Well, here we have these people, time passes, hours move on, and now we're going to have coming up on the 16 hours we've specified for them to remain in their home, and they should move to the school. And indeed, they all move to their schools in turn. Now, right now, there's no way, I stopped the model. There's no way for them to move back from their schools. So we need to put that in as the final component since we're coming up on the hour here. Palette, transition. So we're in the palette for agent, dragged in a transition. We're going to have a timeout of say 8 hours. This is going to be called go home. And we've already done the same thing before. We'll just recapitulate it. Move to where do I move? I move to my home, but it's my home's location. Okay. Schools are actually geographically situated themselves. They know their location. They're imbued with their location. By contrast, homes here have a location attribute that specifies their location. Remember, we drew this from a random set. It's not that the home is bound to some known geographic point, in which case we could just say move to home. It's so if there was a clinic that we had bound to a point in geographic space, we could say move to clinic. But here, the home has a location that we gave it through the population, and we're moving to that location. Okay, so we're moving them to their home's location. Let's go on this here and make sure that we see the proper behavior. We should see them pulse back and forth, going from homes for the first 16 hours. You can speed it up a bit to schools. And then 8 hours later, at 24 hours into the simulation, they should go back home. The cycle repeats. So they'll soon go back to school. And if we speed this up, we could see the pulse of life, as it were. Now, if you were to examine it at a very slow time frame, you could actually see them, like if we were to to get it right to the cusp of 16 hours. Okay, well, I won't try to send, but you can actually see them move along paths and so on. I'll just note, if you wanted to set their speed, you could do so here in Maine. There's actually 3 different ways you can set speed at least. You could set it for the agent. You can set it for, you can set it dynamically for a specific agent. You could set it for the agent type. And you can also specify it for the population, the number of meters per second that they travel. So if we want to have them travel at a slower speed, you could change it for the population to a slower initial speed, say 1 meter per second. I would note that if you are interested in different routes of transport, we could go to Maine, go to Maine, go to this GIS map, and you'll notice that you can set things like the road type. I could set them to travel via bike, foot, rail, for example. I can also parameterize the some aspects of where they get information. I believe it may be no, it's not. I believe that you can use a custom route provider or custom sort of tiles to show the locations, for example, for a map or geospatial imagery. And there's a set of other settings here which can be used to specify things. Shape files can be imported with some limitations, some important limitations for use with the GIS functionality. Okay, great. So that's all we have time for today. I regret not being there in person and not having office hours this week due to me running the meeting. I have an 8-hour drive back on Saturday, which will again allow me to resume a more normal schedule starting Monday. Thank you very much, everyone. Hope that was useful, and I will look forward to seeing you next week. On Friday, we will have a guest lecture by Wade McDonald, who was kindly offered to give a case study for use of an H-based model that he's built with stakeholders. So that will be for our normal lecture session on Friday, that is tomorrow. And I'll probably be there to introduce him and say a few words, and then he will take it forward from there. Thank you, everyone. Take care there.